Hi everyone, and welcome to the Mat 211 review of matrix inversion and determinants. My name is Julia, and I work at the tutoring centers at ASU. So, today we have something a little bit different. Matrices are frequently used in a branch of math called cryptology. Here is a simplified version of something called the Hill cipher. So, say we convert the letters of the alphabet by this table here, where A equals 1, B equals 2, and so on. And we're going to go ahead and encrypt these like this. So for math, we're going to encrypt always in a matrix with 2 rows, so 1, 2. And we encrypt, we fill this matrix vertically by convention. So we go, M, A, T, H. So we just fill one column at a time. So now we've got this key, which in this case is going to be chosen to be this matrix 2, 1, 3, 0 equals K. And in order to encrypt our message here, which is in this form, first we have to convert it into numbers using our conversion table up here. So M is 13, A is 1, T is 20, which you see here, and H is 8. And we see that there. So we just substitute the numbers in. So then, once we have it converted to numbers, we're going to multiply this key by our message. So what that means is we'll have like 2, 1, 3, 0. Oop, let me rewrite that. That looks terrible. I'm good at math, but my handwriting is not so great. Here we go. 2, 3, 1, and 0. That's better. A little better. And we're going to multiply that. We're going to put that on the left of our product in this case. And that's so that no matter how long this message is, so how many columns we have, we'll still be able to multiply it by our key. So, and then we're going to add our message on the right-hand side. So 13, 20, 1, and 8 are converted into numbers message. And if we go through matrix multiplication of that, we end up with something that looks like 27, 48, 39, and 60. And that would be our encrypted message here, this matrix here. And notice that none of these numbers in this case are even in our table. So we wouldn't know, unless we knew the key, how to convert back to our original letters. So let me move on to the next page here because I think it has a little more space for working. And we want to encrypt the word Monday using our key. And our key is the same on this page, and as is our conversion table here. So the first thing we want to do is put Monday into our matrix, message matrix, I guess we can call it. And again, remember that we have to have 2 rows, just like this guy. So we're going to have a 2 row, and since there's 6 letters in this, we're going to have a 3 column matrix. So this will be a 2 by 3. And again, by convention, we're going to fill these letters by filling each column. So we'll have M, O, N, D, A, and Y. Now that we have that, we want to convert these into numbers using our table. So we have M is 13, so 13. O is going to be 15. Put a 15 down there. N is 14. 14. D is 4. 4. A is 1. 1. And Y is 25. 25. That's a 5. Oof. There you go. All right. So now that we have our matrix with our message converted into numbers, Now we want to go ahead and encrypt it. And again, we're going to multiply our key 2, 3, 1, and 0 by our numeric version of our message. So 13, 15, 14, 4, 1, and 25. Now, if we go ahead and work this out, we should end up with 41, 39, 32, 42, 27, and 3. And you can verify this at home. So this is our encrypted version of Monday. Which is our solution. So just as a side note before I go, there are more steps to the actual cipher, the, what is it, Hill cipher? So this is not exactly the same, but if you're curious about that, we urge you to, just Google it. You can find what you're, find how to do the real one and get creative with your ciphers. So before I go, I just want to remind you all that if you are looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our services. Additionally, if you are looking for tutoring services for your specific course, you can use our tutor search tool, which you can find at this main web page here, or by going straight to it at this full link here. So thanks so much and have a great rest of your day.